All right, welcome everyone to our winter series of training for the National Research Platform. Uh, we have two sets of training. Of course, all the details are on nrp.ai/training. So this is a live page that always has the training information. So whenever we announce new training, you'll see details here. This is our February training, the one we're hosting right now. We have two identical sets. Right now we're in set A. So we have the beginner track today on Wednesday, and we have the intermediate track tomorrow on Thursday. And similarly, we're repeating them next week on Wednesday and Friday, where we'll be covering the exact same topics. So if you attend one set, you don't need to attend the other one because it'll be identical, but you're more than welcome to do so. Of course, since they're identical, we'll be uploading them to YouTube on NRP's channel for asynchronous viewing, and we might only upload one set since they're identical sets to avoid any confusion. And the timing for training, if you're attending live, is 11 a.m. to 2 p.m. Pacific. That is 2 to 5 Eastern on all days, and you can of course mix and match. You don't need to attend just one set. And of course, we've asked everybody to register before the training, even though the Zoom links are on here, just to make sure that everybody that joins in is already part of a namespace. Because to follow along the beginner track, like we mentioned, you need to be part of a Kubernetes namespace, which you can check by visiting nrp.ai/namespaces. I'll send it in chat again. And to follow along the intermediate track covers slightly different topics, including using NRP's Jupyter Hub encoder, which are services that NRP has to offer, but also deploying Jupyter Hub. And deploying Jupyter Hub is discussing of how to provision your own custom Jupyter Hub environment. And the privileges needed to do so are considered namespace admin privileges. So if you want to follow along tomorrow's session and be able to follow along with the parts that deploy your own Jupyter Hub environment, please make sure that you are a namespace admin before tomorrow's session, and you can reach out to us over our contact methods, which include our matrix chat, which we host for NRP. The details are on here. And you can reach out in chat, you can reach out via email, you can respond to the registration for the training, but please make sure you are a namespace admin if you want to follow along this part tomorrow. Otherwise, you won't be able to follow along with that part because that would entail an individual namespace that you can test of. And if you're a namespace admin, you can create a namespace for yourself. But if you're not a namespace admin, we won't have sufficient time to give you admin privileges and create individual namespaces to follow along with. So please be careful if you want to join that part. I'm just gonna say it again. Please make sure you are a namespace admin before joining tomorrow's session or next Friday's session, the intermediate track. It requires elevated privileges that there's namespace users and there's namespace admins. It requires the admin privileges to be able to follow along and reproduce. With that said, like I mentioned, this is a live page, so you can see previous trainings are announced in here as well. Once this training is done, it'll be technically a previous training, and new trainings will always take place. At the top, you can see we had a different format for the previous training. It was spread across different 1 hour sessions, and the topics are here, and the video recordings are on here. I'm just gonna show you here. If you click on video recordings, it's all on YouTube. It's part of a playlist. The playlist is still useful. You can check out different topics if you'd like to check it out. But for our live one, basically we're trying out a new format. We're using something called software carpentry to provision the training materials. It's in the form of a web page that is deployed from GitHub pages. I'm just gonna send the link in here. So the link is nrp.ai, nrp-nautilus.github.io / it's a little long, so please copy it from the chat, nrp-winter 2026 training. Of course, the training itself, this is being provisioned from this GitHub repo. So I'm also send it in chat. So this is the GitHub repo. The training pages are from the pages directory, and they're in what the software carpentry format calls episodes. So those are the introduction topics that we'll be going over. And then the actual reproducible code parts that we're going to be going over are the beginner track and the intermediate track. And they're both available in the form of a notebook and a markdown format as well for easy viewership. So you can click on the beginner track and s- go over this asynchronously, and you should be all able to follow along this in your namespace. Uh, you don't have to depend on the live training to be able to follow along with this or the videos. Same thing for the intermediate track. So you can also skip ahead if you'd like to start it off before tomorrow's session. You can also try this out. And before we jump into the code, we'll just give you a brief introduction on what NRP is, what resources it provides, and how you can use it for your research or education. So we can start off if you want to follow along. These are the same training information that you found. We can go over an intro to NRP. So NRP, to give you a brief introduction, is short for the National Research Platform, and it's an ever-growing platform. It started off as a smaller project called the Pacific Research Platform, and it expanded nationally and even internationally. And right now, it's standing at a partnership of more than 80 institutes, as a more recent figure, and includes hardware at various sites. Those institutes that constitute the partnership have contributed hardware to this platform. So the platform itself operates on the analogy we like to use is a potluck model, where anybody can join in hardware and you can actually contribute to the platform. And yet anybody from academia can still use the platform and provision resources. And it includes contributions from the National Science Foundation, the DoD, the DOE, and so on. So you have NSF grants that are running on NRP. NRP itself started off from an NSF grant, and that's how it's growing. And we have international sites that are adding resources as well. And it all operates under one Kubernetes cluster. So when folks join in new hardware, new servers, they're added as Kubernetes nodes. And the cluster itself is called Nautilus. So when you hear the term Nautilus, it's you can think of it as synonyms with NRP. Nautilus is the one cluster that encompasses all resources. So all hardware and software resources that NRP has are running from Nautilus and on Nautilus. And the cluster itself has been running for more than 6 years now, and it's primarily led by us as a team. It's primarily led by researchers from the from the University of California at San Diego, at the San Diego Supercomputer Center, and at the University of Nebraska at Lincoln. So SDSC and UNL, once if you reach out to our support team, you will be answered by someone from SDSC or UNL about user support and cluster support in general. And we primarily host the hardware for the National Research Platform at SDSC, UNL, and MGHPCC. So that's how the project started. It started off from an NSF grant called the Prototype National Research Platform that got the first set of hardware to establish the platform at SDSC, UNL, and MGHPCC. Of course, that first hardware that started off the platform includes different hardware between AMD or Xilinx Alveo FPGAs, NVIDIA GPUs between A10 GPUs and A100 GPUs, and the high bandwidth connectivity between the different sites, and the storage system that is underneath all of this. Like I said, NRP itself, it's one Kubernetes cluster. And that is what the training today is about, is to teach you how to use Kubernetes to be able to leverage what the cluster has to provide. So the cluster is many hardware servers provisioning multiple resources between storage, GPUs, CPU compute, and software services. So GitLab, the ability to run Docker images, the ability to use Jupyter Hub, the ability to use different things, including various software services like Nextcloud, which Nextcloud is similar to the thing I like to compare it to is Google Drive. It's a cloud platform where you can upload files, share files, and document edit, and so on. If you registered for the training, you might have seen that the form itself was from Nextcloud itself. So it's a full suite of software services. And of course, it all runs, Nextcloud itself runs on Kubernetes, just like everything else. And we will teach you how to provision persistent resources, spin up web service. For example, at the end of this training, if you wanted to, you can host your own Nextcloud, for example, and be able to provision your own software services. So the training for today's session is mainly about how to use Kubernetes to be able to leverage the hardware resources. The hardware resources, the figures are always changing, so we're always updating them. We're standing at more than 500 nodes now, not 430, and we're standing at more than 1500 GPUs now, and we're constantly adding more and more resources as we progress and as we organically grow. And storage options for storage to be able to use persistent storage. You'll see that Kubernetes way of provisioning resources is ephemeral. So Kubernetes, and we'll get to that in the technical part, but Kubernetes provisions containers, and those containers are ephemeral in nature, which means when you start up your own, let's say Ubuntu container, uh, it has all the things you expect in an Ubuntu system if you're not familiar with what containers are. But once the container shuts down and you start a new one, it starts from scratch. All your files are gone, or all your libraries are gone. The only things that start from scratch are what is baked into the Docker image. And we'll talk about what that means in a little bit. But basically, to be able to use persistent storage where you can store your code, your files, your data sets, you need to be able to use what Kubernetes calls a persistent volume claim. And that's the way you can provision you can provision persistent storage on NRP and on Kubernetes in general. And by doing so, you can provision multiple file systems. So mainly we have a file system called the Ceph file system, which allows for read-write many persistent volume claims, and we'll get to that in a little bit. But we also have another file system reliant on Ceph, which is the Ceph RBD, which is short for the Rados block device. It allows for block storage. What that means is read-write only. What read-write many and read-write only mean is that read-write many can attach to multiple containers running on different servers and can be a shared volume. Read-write only can only be accessed once, one with a concurrency of one, can be only accessed by one pod, one container on one server. With the trade-off here being that it is faster. That's why you would use this over this, for example. And we have multiple other file systems that we're not going to get into in training, but you have S3 compatible storage on NRP. You have a LinStore file system and many, many services. And to be honest, the two training sessions are not enough to cover everything that is deployed and running on NRP. So your primary source of information is NRP's documentation. I'm going to send it in chat. So NRP's documentation. So we try to make the documentation as live as possible. Whenever we spin up something new, we document it, we tell you how to use it, and we try to make it as reproducible and easy to use as possible. So I'll just show you an example. For example, scheduling in the intermediate section, you can see that we provide you with step-by-step reproducible steps where you see it as for some in the format of a guide where you can just copy and paste and reproduce and look and see the values that you're gonna get. And it's less dumps and walls of text and more reproducible examples. So please, if you're whether you're attending this live or whether you're watching the recording, please make sure you prioritize NRP's documentation. If you visit NRP's site, you can also reach it from this link here. Please you make sure you prioritize your NRP's documentation as your number one source of truth, because NRP's documentation is always updated and it always has the most relevant information. For our training, we're hosting it now in February, so it's got up to date with everything that we've deployed. But say 6 months from now, the cluster will most likely have new stuff that are not talked about in our training. So please always check out NRP's documentation and keep them as your source of information. But for the sake of the training, how do I get started? You've already gone through these steps because I'm assuming everybody here on the call at this point is part of a namespace and you've already gone through CI logon and you have a namespace to follow along. Where should I ask for help? That's the most important takeaway from this because we're hosting training. Whatever you don't retain, whatever we don't explain well, whatever you don't get to try out on your own, will always be here on Matrix if you follow the Matrix chat. So I'll copy this link and send it. So this is a web-based element client for NRP's Matrix support. So Element is just a Matrix client. So we host our own Matrix server. What that means is that we host a chat server. It's very similar to Slack if you've used Slack before. And the server itself, you can use whatever client you want, whatever is out there for whatever US is using. So I have Element on my phone, for example, and I can access this chat as you can see here in these screenshots from my phone. You have the freedom and ability to pick whatever client you want to use. But to make it easier, we host a web hosted element for your use as well. So the link I sent, element.nrp-nautilus.io, I'll show you here. Sorry, I don't use it much, so this is what it shows when you visit it for the first time. You can either create an account or you can just sign in with your username, password, or a single sign-on. And once you're in, it takes some time to sync because I'm in a lot of chat rooms, but once it syncs, you'll be in the same client that we have that is shown here in the screenshots. So please, first step in following training is please make sure you're on Matrix. And if you're able to join right now during the call, please make sure to do so. Because that means you're safe. At this point, you're safe. If you can't follow along the training, you'll find us in chat to be able to help you follow along with. And if you want to do stuff that we don't cover in the training or you want to test out different stuff, this is how you get hands-on support. And we try to be as real time and as fast as possible in answering everybody. Please don't email us because the cluster has thousands and thousands of users. So even if we have the capacity to reply back, you'll be waiting for a long time through email. Your best bet at fast support and hands-on support is Matrix because that's where the community lives. So any cluster news, we posted in NRP news, which is a channel. You can see it on the side. It'll show up on the side panel. Uh, Anything you want to ask, there's different rooms for different topics. For example, LLMs, we have a room for LLMs, we have a room for different AI applications. You can create your own room for your group and use it for your own chat, for example, and make it a private encrypted room and do all of that as well. And I see a question about if the recordings will be posted on Matrix. We will post the announcement for the recordings on Matrix. So NRP News, so on the NRP News channel, we will say that we've posted the recordings, but the recordings will be referenced both on NRP's website. So when you visit nrp.ai, we'll reference the recordings here, we'll reference them in the training page, and we'll reference them in Matrix. But to where they'll be hosted, we're using YouTube, and we have a YouTube, sorry, this is my YouTube, but this is NRP's YouTube. And we're going to be adding a new playlist for this training. And we use YouTube just for the ease of viewership, and so they're retained so users can view them whenever they want. And cluster policies, we'll go over them in the training and what you can do and you can't do. But right now, at this point, we're ready to go over the technical parts and start doing the step-by-step parts where you can follow along, follow what we're doing, and follow along, follow what you're doing, and basically reproduce, ask any questions, and start using NRP. So this is the exciting part where we're going to be hands-on and where we're going to be doing the steps ourselves and requesting resources, running interesting workloads. So I'm going to pause here and ask if anybody has any questions. Please feel free to ask now. You feel free to send in chat, feel free to raise your hand, feel free to directly unmute and ask before we get started. And For the format, since this is a 3 hour session, we're gonna get started now. So there's a question, will we be discussing storage in detail? Yes. So we have various file systems, various options. We'll show you how to provision them, and we'll go over examples where you can actually request storage, persistent storage, and follow over them. And the website I'm using is in here. I'm sending it in chat. So the web page or called cart and free for training is here. And the repo for it with the code is here. And those two pages will also be linked in training, and they'll be posted in the web page, and they'll be posted with the recordings as well. And since it's a 3 hour format, af after we get started, we'll take a brief break so everybody can catch a breath, grab a cup of coffee, also ask any questions. And at the second hour mark, we'll also take another break just to make sure it's not overwhelming, it's not an info dump. But for this to work the best format it can, please feel free to ask as many questions as you can, and we'll be happy to answer all of them. And please, after this session and tomorrow's session and all the sessions are done, please reach out to us with as many questions as you can. The expectation is that you'd have questions after training is done, so but please don't shy away from asking. We'll be there on Matrix, happy to assist everybody. All right. So to get started, this is the GitHub repo, and these are the pages. And the platform we're going to be using for training is Jupyter Hub. So one of the things that NRP has to offer, and anybody on this training session, not that everybody's part of a namespace, can use is Jupyter Hub. So NRP has two Jupyter Hubs, Jupyter Hub West and Jupyter Hub East. And all of this information is in the beginner track. So you have the repo here. This is where we're going to be using. So if you're inside the repo, the beginner track, if I click on it inside of GitHub in my browser, I see all of this information. So this is what we're going to be going over here. This is what we're going to be using as our guide. So you have the Markdown notebook here. This is the beginner track. This is our session here. So the tutorial environment, like we said, we're using our Jupyter Hub. So NRP's Jupyter Hub, it lists here in detail that you need to be part of a namespace to be able to use it. And we're using the West one just for the sake of simplicity to make sure everybody's on the same platform. This is Jupyter Hub West. On first visit, you'll be logged out. It says sign in with authentic. This goes through the exact same authentication that you go through for the portal, for the website, for everything, and for Kubernetes itself. So if you can get through that one, you can get through this one. So first step is log in. Please make sure you can log in. And if you face any issues that say denied, permission denied, that means you're probably not part of a namespace. Feel free to ping me in chat and I can take a look at it. But this is the environment we're going to be using. And the reason we're picking Jupyter Hub is that we can have a consistent environment for everybody on the Zoom call. But basically, this is my terminal. I can follow the exact same training along in my terminal without having to use Jupyter Hub. So it's a preference thing. The thing is here, you're going to be using a tool called Cube Control. That is kubectl. I'm just going to zoom in here a little bit so it's easily viewable. So this is Cube Control. If you can list Cube Control version, that means you have Cube Control installed. You can use this locally if that's what you're comfortable with, or you can use Jupyter Hub as the local environment. So this tool allows me to talk to the cluster. So I have the cluster, which is a remote resource that has all the resources I want. I want to provision GPUs, I want to provision CPUs. That's my remote environment. To be able to talk to it, I need to have a local tool that allows me to talk to it. Because I have GUI tools, I have tools like Jupyter Hub that I can say, oh, give me this much RAM, this much GPU, but they're limited what they can do. Kube control and Kubernetes in general allows me to do everything that I want to do. So kube control doesn't matter where it's running from, as long as it's my environment and I can authenticate from it. So not a public computer where anybody can steal my access and do malicious uses. A local environment that is mine, and that could be your Jupyter session. So once you've logged in, I don't care how much memory and cores I'm using. So one core with 2 gigs is more than enough because or two with four, because the resources I'm requesting here are just to run an environment that allows me to run kube control. So what image I run here, I'm also indifferent, but I'll run the PyTorch one just because it has plenty of libraries and I can just click start. And that will start my environment. And again, just to make sure everybody is on the same page, we're just using Jupyter Hub just to have a terminal environment because we have multiple attendees. You might be using Windows, you might be using Linux, you might be using Mac, you might be using different environments, different IDEs. So having this command, kube control, work and run on your OS is a little bit of a different process for everybody. And we've listed how to actually get kube control working. But mainly the main thing we want to reference here is we're in part 0 here, installing and configuring kube control. This part we'll be doing in Jupyter Hub, but like we said, you don't have to use Jupyter Hub. Ideally, you would have it installed and configured in your local terminal. And the way to do so is different for every OS. So we've linked the NRP videos from YouTube that show you how to install it on different platforms. So if you run Linux, there's running kube control on Linux, and we go step by step together on how to install it on Linux. For Mac OS, it's slightly different, and for Windows, it's slightly different. Oh, no. Oh, sorry about that. Now going back, we're in part 0. We want to use kube control. And the first step is to start our Jupyter Hub environment. I hope everyone is able to do so right now. I'm just going over the chat. All right, if you can't log into Jupyter Hub, please ping in chat. As you can see, this is what you expect to see. Successfully assigned, attach volume, pull image, and then it starts your notebook environment and your Jupyter lab. And for image selection, you don't have to we don't care that much because they all provide more tools than we could need. But for me, I chose the PyTorch one because I like to use that one because it comes preloaded with a lot of tools. And of course, here the resources you select here are not the resources you want to use. So if you have a, uh, AI use case that uses GPUs, you'll be using that over kube control, not in here. This is just for having a terminal environment where we can use kube control. So I chose the PyTorch one. I chose, if I remember, 1 or 2 cores. I chose 4 gigabytes of RAM. That's more than I need because I'm just using it for the terminal environment. And at first time joining in, this is what it looks like. I'll just delete all of these just to show you a clean slate. So at first time visiting, this is what it looks like. And I have a terminal here. I can click on it and I have a terminal environment. I can also add here and can have multiple terminals. Can put them like this. And I can just, for example, this is my training. I can just get the beginner track, download it from GitHub, go over my downloads. and just drag and drop it. And I can open it in here and I can open it like this if I want. And now I have my terminal on the left and my notebook on the right, and I can just follow along the same steps. And this is identical to what's in GitHub. And sorry, just checking out user issues. So I see one user is saying they don't see CUDA. That probably means you picked a different image, and that's perfectly fine. Or do you mean CUDA here? This is my persistent storage. You don't have to see the same files. These are my files basically. So if I ls, you can see these are my files. I can basically remove all the CUDA files and it won't change anything because these are files that I added, not the files that should be here. So the panel here, this is your persistent directory. You get by default, you get 5 GB of storage. If you need more, we can always extend it. And you can drag and drop files here. You can download to here from terminal. You can start notebooks here and so on. So whatever you save in your home directory, which is the directory I'm in. So the directory it starts in, which is denoted in the shell as a tilde sign. This is my home directory. If I create a file called hello on terminal, it shows up here. And that's for me to use. Each person gets their own persistent storage. So your files are in here are private from everybody else. So you can think of it as your playground right now in training. Uh, Sorry, I'm just answering users in chat. Yeah, so this is a very interesting question. So the ID Jovian, this has a very interesting backstory. So this is the default Jupyter user. So the images that you're using, even if they're called the NRP PyTorch one or the NRP this or NRP that, the images you're using are based on the default Jupyter Hub Docker images. And the Jupyter developers, they use the term Jovian for their default username because Jovian, if I remember correctly, Jovian means an inhabitant of the planet Jupiter. But Jupiter is with an I and Jovian is with an I. But for Jupiter with a Y, it's Jovian with a Y. That's from my recollection. If I'm mistaken, please, or anybody that knows the backstory, please correct me. And now I hope everybody's in and everybody can follow along. Hope no one is having any issues. Like we said, we're here, we're in this environment. So this environment assumes I don't have cube control. So if you run cube control, it'll say command not found. And for me, I'm setting I'm setting a default environment. I'm starting from scratch. You should be able to follow along these exact steps for your different OS, but but what was I gonna say? So you can follow along those exact same steps for your OS, but if you want to go more detail on how to configure your environment for your OS, for your local computer, like we're doing Jupyter Hub, you can follow the steps in this YouTube playlist in here. And to split the screen, basically, this is what I looked like from scratch. So this is what it should look like from scratch. If it's here empty and with ls is empty, that's perfectly fine. They start off empty. And this is what it looks like. And I can just open a terminal and I can just open another one either from the add button here or the add button here. It shows me the launcher, and I can just open another terminal. If I want to split them, I can just drag and drop this. Then I can just add and drop, drag and drop another one. And to open the tutorial material in a split screen like this, all I did is download it from GitHub, from the download button, from the Python notebook. And then I went to my downloads and just dragged and dropped it. And now it should show up with ls, and I can just open it. Once I open it, I can just drag it to split. And sorry, I'm just taking a look at the instances started. And now we can, and this is sort of not mentioned, but the images you're picking in here, they're all Ubuntu based. So they're all Linux. So you're following the same steps you're following for Linux in this environment. So the first step is to install kube control. And of course, for any tool, your first guide is to follow along NRP's documentation. So right now we've listed, at the time of making this tutorial, we've listed the current way of installing kube control, but always follow NRP's docs. You can see in our official docs, we say follow along the official Kubernetes ones. But since this is up to date, you can follow along. We've sort of hard-coded them into the notebook. But if that changes in the future, then these commands will stop working and you will need to resort to the official documentation on how to install. But basically, you need to the curl command, but this installs the kubectl binary. You can see we're using the AMD 64 variant because most nodes are on NRP. They're AMD based. So let me show you the Jupyter Hub spawner. So you can see here the default architecture is set as AMD 64 because most nodes are AMD 64. And there are some ARM nodes, but you have to explicitly ask for those to land on them. And once I've downloaded, I can just install it with a second command. And then I can just reload my bash environment and I can just, oh, sorry, this is from my previous plane, so you shouldn't be able to see this. If you want to reload your bash environment, all you have to do is run this. And then I can run kube control. And this is also a remnant from something I was testing, so ignore my error messages. You shouldn't see any that are yours, and you can just run kube control. You can do client as well. And this is step one. At this point, you should be able to run kube control version, but that doesn't mean you're connected to NRP just yet. You need to follow the same with the same steps. Now, I see a question in chat. I'm assuming we have to install kube control differently based on our OS. Yes, that is exactly right. For Jupyter, it's the same steps for Linux. For Mac OS, it's different. Brew install kube control is all that you need on Mac in more than 90% of the cases, unless you have something special in your local OS setup. For Windows, you can follow along the Kubernetes steps. The Kubernetes website lists them, and you can follow along the video that we have linked. So in the playlist, the YouTube playlist, we show you all the steps from installing kube control to installing kube login, which is the next step, to actually running and connecting to NRP. And source bash rc give me no file, no such file or directory. Are you running inside of NRP's Jupyter Hub? If so, can you try just running bash and see what happens? And I'm just going over. Oh, sorry. All right, we're gonna be going over Cube login in the next step. I'm sorry, Elizabeth, I'm just seeing your message now. It did look like it took a couple of minutes to start. I hope it's running now. All right. All right. Looks like everybody's ready for step two. If you have any issues, please tell me now. And I'm running clear to clear out my terminal. I can list my Cube control version. The next step is installing something Cube login. So Cube login is a plugin for Cube control that allows me to use the authentication platform that we used. So you know how you logged into the website using something called Authentic, and that used CI logon. That's how everything on NRP authenticates. So everything that needs login, that's what it goes through. And for Cube control itself, as a command line tool that I'm using to be able to go through that authentication, I need to install something called Cube Login. And that is a little tricky and a little too specific in how you set it up. So please make sure you follow along these steps through the dot and not deviate from any of the steps because uh, any minor deviation from the steps, it could cause it to fail in logging in and not allow you to log into the cluster. Of course, if you face any issues, we're always more than happy to provide support. But basically, the steps, if you're on Linux or Mac OS, the easiest way to install Cube Login is through Homebrew. So the first step to install Homebrew, and this is directly from Homebrew's website. So if you just Google install Homebrew and click on the first link, this is the exact same command that is here. And I just can copy it and paste it and hit enter or return, and this will install Brew for me. And if you have Windows and the command to install kubectl worked for you, that's perfect. That's awesome. Because Windows, that's just from my own personal experience, Windows is the most tricky of the mainstream OSs to get kubectl and kubelogin to work on. And after it's installed, you might need to source the bash profile file again, or run bash again, or run this command in here that they've linked here, and then you can run brew. And if you can run brew, sorry, I think it was brew dash v if I'm not mistaken. Here we go. Brew dash v. Actually, let me make my font a little bigger. Brew dash v. This shows me a homebrew version. That means I have brew installed and I can follow along to the next step, which is install kubelogin. So that's just brew install kubelogin. And one thing to mention here, after training is done, like we mentioned, Jupyter Hub is an ephemeral environment. This is installing, if it installs any dependencies outside of your home directory, on next start, you won't find the same configurations. So this is just to have a consistent environment where we can all follow along and where you can install kube control without depending on your OS configurations. And once kube login installed, just give it a minute. You got the message brew command not found after you installed it and after you saw the same output. You might need to run this line here in next step. So next steps run this command. So this refreshes the path and makes sure it runs homebrew from your path. Okay, let me try again. Looks like it's a little slow today. And This is from messages from users. If you run kube control, OIDC dash login dash dash version, uh, if this doesn't go through, that means kube login either isn't installed or isn't configured right. Because OIDC login, this is what the this is what kube login does. So let me show you an example. If I run this and for me it went through, for you if it doesn't go through, you either run this source and reload the bash profile. I'll send it in chat. Or you run bash, just the command bash, or the same command. Sorry, let me, where was it? The eval command that Homebrew gave us. And it's if it says it doesn't know what OIDC means, that is still a kube login issue because kube control doesn't know what OIDC login is. Installing kube login is what tells it what OIDC dash login does. Oh, my bad. That's right. I uh, I am in a new bash shell. That's why I couldn't see it. Here we go. Thank you, Bill. So this is the command. And at that point, you should be able to list the kube login version. So I'm assuming everybody should be able to follow along up to this point. Does everybody have it right? Is it working for everybody? All right. The next step is to down, and if it's not working, please feel free to either unmute and ask or send in chat. The next step is to download the config file. So the config file, you can see the link here. So this is the page that is in docs. Uh, just Kamalika, did do you go over brew install cube login? Let's go one by one. So you guys ran this command, right? So just going over it real quick, and please feel free to send in chat. You installed brew cube login and you ran, sorry, and you ran the source command or just bash to start a new shell. If brew is not installed, you have the, let me, sorry, I'm just gonna pause and sorry, I'm just checking user issues. looks like not a piece. So please make sure you install Homebrew with these commands before attempting to install Cube Login. Sorry, with these commands before attempt. Sorry, getting lost. Please make sure you install Homebrew with this command before attempting to install Cube Login. Otherwise, it's not going to go through. So for Chocolatey and Crew, uh, we're gonna go into break very soon, so I can show you step by step. But I don't have a Windows environment to reproduce. I can show you in the next few minutes. But as a quick solution, we do show you in the video how to set up for Windows. If you're using Chocolatey or Crew, the recordings here and running on Windows. This goes, sorry, this goes over Chocolatey and Crew. And for Srikant, I saw your instance. I can access it from my end. It looks like Brew wasn't installed. That's the issue. After installing Brew, I'm able to use Cube login. All right. So at this point, can everybody? Sorry, go back to my environment. At this point, can everybody run kube controller idc dash login dash dash version in Jupyter Hub? And are you able to see my screen well? It's not rendering well for me. All right, sorry, let me try stop and reshare. There we go. All right, and now yes, you can cube login. So cube control, cube login, you don't care about the version you have installed. If it mismatches between client and server, that's perfectly fine. And the next step is to download the config file, which I'm going to be showing you. Just I'm having temporary Chrome issues. Let me try Firefox. Now I'll share in a second. All right, sorry about that. I was having Chrome issues. I switched to Firefox. Here we go. And for users who are on Windows and using Chocolatey and Crew, please feel free to use Jupyter Hub as your environment, and this way you don't have to worry about Chocolatey and Crew. And we can go over installing in Windows during the break. I hope everyone can see my screen now. I'm back in Jupyter Hub. Now the next step is to use the config file. So this is step 3. And when you click on the link, you can see this is the NRP's doc page. If you scroll down, it says install kube control, the steps here, install kube login. And if you click on install kube login, it takes you to the kube login repo and shows you the steps. So with different OS, different steps. Step 3 is download config file. When you click on it, it downloads the file. So you can download it and grab it from your downloads and just drag and drop it, or you can click the link. If you right click, you can copy the link, and then in terminal you can wget, which allows you to download, and just paste the link, and this downloads the file. So you can see with wget, here's my config file. Or likewise, I can just go to my downloads, drag and drop it, and it'll show up as here. Now, if you're an old-time user of NRP, at one point the policy was that this file in itself was private, so each user got a custom file that authenticates their identity, and you weren't supposed to share them. But right now the entire cluster has the same file, so yours will exactly look like this one, in exact, not a single thing off. And this will use kubelogin and it will authenticate you through kubelogin. So to show you what that normally looks like, so I'll sorry, clean. So this is what a first time logging in looks like. So anything kube control. So kube control, for example, get pods. This lists pods in my namespace. First time using kube login, this takes me to a browser window and I'm having Chrome issues still. But basically, this takes me to authentic. This authenticates. Then I can just close this, and it'll show you that it's okay to close, and then this authenticates. Of course, when Chrome is working fine. So I'll just ignore this for now and stick to Firefox. But in your Jupyter Hub, you don't have a browser in here. So if I take this file, the default file, the same way it is, and it's in here, and we follow along the same steps. So the steps in here, and is that so Kubernetes looks for the config file in my home folder. So this is my home folder. It's shortened by tilde. So this is my home folder, and kube control looks for my config file in .cube/config. So this is where it expects to find my config file. So this is where it needs to be. So I'm in my home directory. If I ls-a, this lists all directories and files, including hidden. And you can see I don't see a dot cube, so I can just make directory / cube. Oh, never mind. Must have missed it somewhere. Oh, my bad. It's right here and I'm not seeing it. Sorry about that. In either case, you can do make directory -p in case it already exists. This way it doesn't fail. It only creates it if it doesn't exist. Then I need to copy or move. So that's either CP or MV. My config file into .cube, and I add dash config to rename it so it's config. So you can just do this. This moves my config file to dash cube, and then I can just list the contents of the file. And I should see my file in here. If you don't have a .cube, that's perfectly fine. You can just do a make directory. Just adding the dash P. Dash P handles if it already exists, so it doesn't fail. And just to show you the failure that would happen with the default configuration, because the default configuration expects to run on a local computer with a computer screen and everything. If I run kube control and then any command, let's say get nodes or get pods, you can see here I'm seeing failure and it trying to open web browser. That's the first issue. The second issue is that it says you need to open localhost at 8,000, and localhost is a local accessible IP environment. So it's inside my container, it's inside my Jupyter Hub workspace. It doesn't exist in the outside world. So if I take this and paste it in my browser directly, this doesn't mean anything. This does not reach to the inside of the Jupyter Hub environment. So in headless environments that don't have browsers and don't have exposure to the outside world, the way I would edit my config file, and this is all in the documentation, but the way I would edit it is I would take my config file and I would do a couple of small modifications. So, and you can see them in here, just doc page about Cube plugin and common issues. Just pasting it in chat. You can see here, these are the three most common, actually four most common issues that users face depending on environment. So keyring errors, we see this a lot with Windows users. So in the file, you see token cache storage is keyring. If you switch this one out to disk instead of keyring, and I'll send this in chat. So this is a fix to a common issue. Another common issue is that users sometimes have local servers running on their local computer and are sometimes using the port 8,000. So this is dependent on your local setup, but you have if you have a conflict at 8,000, you can change this to use a different port. Another issue, especially with the folks that use WSL and Windows for when the Windows subsystem for Linux, is that the browser command. So this uses the default browser, but if you want to use a specific browser, you can just add a browser command like this. So you would follow the same parameter formatting. You would add it like this. And if you're using WSL, this does point to the Chrome browser in your Windows OS. If you don't use Chrome, you use something else, you point this to your actual browser. And so this allows you to open a browser from WSL, but there's the option to not open a browser at all, which is what we're going to be doing in Jupyter Hub since we can't open a browser in here is add these two. So grant type device code and skip open browser. So I can just copy those two and add them as parameters in the bottom. So use the same format, which is spaces, then one dash, then the two dashes, and then another one is like this. And this is what we're going to be using. I'm going to copy and paste it in chat so you can just copy and paste it yourself. Oh, it's too long. Just going to copy and paste the last part. So from users here, you can just copy and paste this. You can see I'm modifying config parentheses one. So this is the one I edited. So this is the one I modified. I'm going to move it to the right place. So that's config one. I'm going to move it to dash Q config. And then when I list its contents, you can see my modifications here. And to open your config file, since it's in the hidden directory, I'm not sure if you can open it from here, but to be honest, the easiest way to reopen it now that it is in .cube is to the easiest way to open it then now that it's in .cube is to move it back. So and then you should see it here. Unless there's a hidden option that I don't know about that allows you to see hidden files in here. And I see a question, why are we modifying the config file? The reason is that because the config file takes different parameters, and the different parameters are for different environments. So when we're running in Jupyter Hub, for example, there's no browser. So you modify it to add the commands that skip the open browser and that work in an environment that doesn't have a browser. But the most common case is that you're running kube control locally, where you do have a browser, and then it's just easier to use the browser than to go an extra step with the device code, which we're going to show you in a second. And the other reason is that because different OSs require different configurations. So it is a common case where users have to go in and modify the config file in case they see issues. Of course, it's an iterative process. So you can see here, this is what happened when we didn't modify it. And if we add the fixes to the default one, then it's going to break for a different use case that a different user has, and so on and so forth. But after you do the modifications and move the file, you can move it back by switching. Of course, you can also modify it with the command line editors like Vim and Emacs and so on. And to answer your question, the main reference to the modifications is here based on the environment. But for this is based on our documentation. So we document the pain points that some users might have. For here, for ease of access, they should be added here. We are going to add them in the updated version, but basically the edits that we added are the ones that I've shown and sent in chat, which are here. And if you edit it in the GUI editor in Jupyter Hub, let's say this is my file, for example, and I edited this, it's just file and save file. And then I can just close it with the saved edits. Or Control S or Command S on a Mac. So Control S does go through. Let me show you an example. So if I remove the R from browser and Control S or Command S and then exit, then reopen it, then it's right here. Of course, like I said, you can also resort to using Vim or Emacs. If Vim, for example, is not installed, you can just use sudo. So this is Ubuntu based. You can just do sudo apt update and sudo install Vim. But like we said, Jupyter, like everything that is running on Kubernetes and on Nautilus, it's a container. So this is ephemeral. When you install Vim this time, you won't find it the next time. But this is just for like there are more complicated setups. You can start your own Jupyter Hub environment. You can build your own Docker image that is the same as ours but has Vim installed and so on. And now for the good part, everybody should be able to do kube control, for example, get nodes, and this shouldn't see any issues, but that did not happen. Let's go back and okay, I didn't add GoIDC login to my bash path. Let me try again. Okay. So kube control get nodes, this worked for me. Now, for some of you, if you've used it before, it might go straight directly. If you haven't used it before, what most likely will happen is that you will see a screen that says paste this command in your browser. And you see. Let me see what I did. So device code, skipping open browser and clicking OK. Now let's try again. So this is what it should look like as a first time trying it. Gives you this link and you copy it and paste it. Now I'm going to open this in a private browsing to show you what happens. This command needs to be pasted in a browser where you can authenticate and federate your identity. So if I open it with private browsing, it's going to take me to login. From here, NRP doesn't take usernames. You need to actually use CI logon. So you click this page. And then you click your own same identity provider. So if I have a Gmail account and I go through that, there's no way to tell that's the same user. I might get shut down and I'm gonna authenticate as the wrong user. So you need to use UCSD and not UCSD for me, UCSD, then use your own credentials, just showing you what it looks like from my side. Then just go through two-factor authentication. Once this is done, continue login. Takes me to redirect. And you may close this page now. I close this and here we go. I'm logged in. Now on second time, I can just run kube control get nodes, kube control, and then follow along. So at this point, you should be able to list NRP's nodes. You can do something like kube control get nodes and just list the top 5. So you should be able to list this here. And this lists the first top 5 nodes, alphabetically, of course, not top in any sort of favoritism. And we're gonna pause here. I'm so sorry. This ran a long time to this point where, as promised, we're gonna give you a break. So right now it's in my local Eastern time, it's 3:34. For Pacific, that's 12:34. Uh, to make up for the long lost break, how about we come? It's 35 now. How about we come back at 12:50, which is 15 minutes from now, to give everybody a good break to grab lunch or grab coffee. And this will give us the opportunity to also catch up if anybody's having issues. At this point, you should be able to run kube control get nodes. If not, please let me know. I'll be here. I'll just pause recording for now. All right, thank you everyone for coming back to continue on with our training. So we're going to be going over some Kubernetes basics that show you how to provision resources on NRP. So first thing, since we have kube control up and running and happy now, you can check kube control's version. If these two versions don't match, that's perfectly fine. Uh, this one is a client, sorry, if the client version and the server version don't match, that's perfectly fine, regardless of customize. So we don't have a requirement for the Kubernetes and kube control version for the client itself. You can follow along just fine, even if it doesn't show 135.1. And the second thing is, if you look and run this command, it should say Nautilus. So my current context is that I'm running in the Nautilus cluster. At this point, this means I am running inside of Nautilus and I can just follow along and I'm connected to the cluster. I can verify that by running kube control get nodes. And this lists me more than 500 items. And if I look at what they are, these are servers. So this is the list, the name of the server, the status, role, a role I don't care about, age I don't care about, and version I don't care about because they're all either running the same version or in the process of being updated. But basically each one of these lines is a server. So in Kubernetes terminology, a node is a host server that I can use that has resources. And each one of those is a server that my containers can run on and request resources from. And that's what we're going to be doing. So as soon as I can list my nodes, part two this part two is the website. It's what we've been doing. So if I go to nrp.ai and I log in, I'm logged in. You can see since I've already logged into Jupyter Hub, this went in instantly. I can go to user and namespaces. This is the exact same thing as visiting this. I'll send it in chat. Namespaces. And I can see the namespaces I'm part of. So for me, for example, where's my search? This is the namespace I'm going to be using, which is called MFSADA, which is my namespace. For yours, you're going to be seeing your namespaces. For the folks that I added to the temporary one, you should be able to see this. So your tree is going to look like NRP, CSD, NRP dev, then MFSADA, then MFSADA dash temp. You'll be able to use the dash temp one. And that's why we said we need to get the name. We can set it as the default namespace. So when I copy this command over and paste it and change it to MFSADA, I can just run kube control, get pods, and this will list the pods that are in the namespace MFSADA. If I say dash n MFSADA, I'm explicitly listing the namespace to look at. So let me give you a different one. If I list the ones in default, it says no resource found. If I list the one in coder, for example, I can see a whole lot of pods that I don't care about. But if I set mine as the default one, then I don't have to explicitly set it every single time. I can just say without default namespace and it'll default to mine. And of course, if you can list the pods in a different namespace, that's fine. Everybody can do that. That doesn't mean you can access a different namespace you're not part of. So for your namespace, the folks that can see the stuff you have in your namespace are the other namespace members. So as a namespace admin, you get to specify who's in your namespace. And as a namespace user, you get added to a namespace where the resources you provision in that namespace are accessible for others. So say the namespaces for a classroom, all the classmates that are under the user role can access each other's resources and containers, persistent storage, and so on. And resources in general, everything you request is namespace scoped. So if I request a volume, I put my data set in that namespace. I can't access it from a different namespace. I need to be inside the scope of my same namespace. And like we said, when I provision persistent storage, that is being provisioned from servers. So storage servers, which Kubernetes calls nodes. When I request GPUs, they're also coming from nodes. And to look at GPUs, different nodes and different GPUs, the nodes themselves, the servers have what Kubernetes calls labels. So to show you some examples of labels, there's a label called nvidia.com/gpu.product. I know it's not an easy naming convention, but that's the naming convention that NVIDIA uses for the labels. And each node that has a GPU has a label with the has this label with the value of it. Here, value equals some value, with the value being equating to the GPU type. So if I get kube control dash nodes, get nodes, this lists all of them. If I say dash L, this adds a column for the label. So if I specify this label, for each node it lists a new column. Let me show you the difference between the two. Is that with dash L, it added the column for the GPU type. So GPU.product, you can see here. So for example, this is a host server at the California State University at Chico. It has Tesla V100 GPUs. So that's how I list the labels in Kubernetes to find out about the characteristics of nodes. Of course, doing so in Kubernetes is a little too complicated because you're going through the command line. If you want to see them in one page, we have this one web page that is like a spreadsheet. And you can see all the exact same nodes. So you can see them here. The ones that have issues and are under maintenance are color coded in red. The ones that have special labels for any issues or reservations are those are called taints in Kubernetes are also listed here. GPU type, you can filter. For example, I'm looking for an NVIDIA A10 GPU. I can say that it equals A10. This will list me only the servers that have A10 GPUs. Then I can see how much CPU is available. This is in cores or the available ones. How much GPU is available. Looks like the A10s are currently under heavy use. So you can see the ones that do have GPUs available are on here. And for example, if I'm looking for FPGAs, I can see which nodes have free FPGAs, memory, and so on. And I can get an overview of the available resources on this page. I'll send it here, send it in chat. Of course, you can still access the same exact same thing from under user and then resources. And of course, Kubernetes in kube control allows me to do a lot of things. So I can get into very granular details on how and where I want to get provisioned. So I can say I want this exact same server. Don't land me anywhere else. And or I can say land me on a server with an ARM processor, not an AMD one, or an AMD, not an Intel one for x86 and land me on this type of GPU or this type of memory and so on. And this is all enabled by node labels. So the labels themselves are very characteristic of the nodes that host hardware. And from there, we can look at nodes, we can specify nodes. And if I don't specify land me on this or that, Kubernetes schedules me based on availability. And it goes into deeper detail. For example, you can see topology.kubernetes.io/region or /zone are two Kubernetes default labels as well. If I add them as columns, just to show you, just shows me the region, which if you're an AWS user, you might be familiar with this. So we have different regions, US West, US Central. Of course, like we said, the cluster itself is international. So you can see Pacific here. This node is actually in Korea. So the region is Pacific and the zone is Korea. Zone in the United States, they're more granular into the actual campus that is hosting hardware. So UCSD, and not to Clemson in North Carolina, and so on. And this is to get a brief overview on what is available in terms of hardware. Now, to actually use it, the simplest form of using the resources is what Kubernetes calls pods. And pods, if we were to define them in a definition, they're the smallest unit of running something in Kubernetes. So everything that runs code, that runs workloads, that runs containers, all boils down to pods. So when I run a batch job, if you're coming from the HPC world, when I'm running a batch job in Kubernetes, that job is launching pods. When I'm running a persistent deployment that is spinning up a website or a web service, that is a pod. My Jupyter workspace right here, this one is a pod. Actually, I can show it to you. So if I go kube control, get pods in the namespace Jupyter lab, I'm not actually going to show everybody. I'm just going to search for the keyword MFSA. Sorry, or mine. Yeah, MFSADA. So you can see here in the namespace, in the Kubernetes namespace, Jupyter Lab, there's a pod called Jupyter-MFSADA-40 is at ucsd.edu. This is my exact instance. This is what I'm running from. So it's looking at itself. You can see 85 minutes. That's when I started it, when we first began. So everything that runs within a pod. And to show you a brief example of running your own pod, and you can follow along with this. So this is how Kubernetes defines anything. Anything I request or submit can be written in YAML, and this is how the YAML syntax works. So it's white space sensitive, so there's indentation, and it follows a different specific syntax and fields. And it's okay to not memorize how to provision a pod. So it's okay if I delete this, you don't have to know how to type it from scratch. You only need this as a template that you can elaborate from. This is a default one, and you can go from here. And I'm just going to copy this, and I'm going to show you an example. So this is my home directory. I can just create a new file. I'm going to call it my-pod.yaml. And what I call this doesn't matter. It's for me, for my own library, my own reference. And I'm just going to open it inside of Jupyter Hub and paste it in here. Now, this is a simple pod. And just to give you a brief overview of the fields, the API version, we don't care about this. We specify it the same way it's given in the templates. Kind is the kind of the resource I'm requesting. Here I'm requesting a pod, just a singular pod, nothing fancy. Metadata needs a name, so I can't take this out. My pod needs to have a name, and this name needs to be unique within the scope of my namespace. So if I run a pod called test pod, it's okay if there is no test pod in my namespace. So I'm running in namespace MFSADA. I don't have a pod called test pod. So I can launch this. But let's say I have a pod. This pod is called proxy dash some other stuff. If I name my pod like this, it's going to conflict. It's not going to let me create a new one. If I run the wrong command, it might understand what I'm doing as an attempt at modifying, not creating, and that could lead to a mess. So make sure the name is unique within the namespace. If there's in the entire cluster, if there's another pod called test pod in a different namespace, that doesn't affect me whatsoever. Now, the pod specifications, the pod is a wrapper for one or more containers. So yes, this pod, I can add containers. I created this one. I can add another one, and this should work. Assuming the way I do it is by keeping the container names unique. And I can just do this. And like how the pod is unique in the namespace, the container should be unique in the pod, but not in the namespace. I can, if all of my pods are just one container, I can always name the container or dev or whatever I want because it only needs to be unique within the same pod. Now, when I schedule this, it lands on the same node. So one pod runs on one server. That doesn't mean other pods don't run on the same server. That only means that one pod doesn't get shared across multiple servers. So my limits here and my requests, these need to be available within one server for me as a user. So if I launch a pod and my image here is Ubuntu, for example, I can also say Ubuntu-2004. 2404. These resources need to be within one server. I can't go around asking for 10 terabytes of memory because we don't have a server that has 10 terabytes of memory. And you can check this out here. But for the sake of argument, that doesn't mean I can't use 10 terabytes of memory. That just means I can't use 10 terabytes of memory with one container. I have to launch multiple pods and one in parallel and launch multiple pods. And that's where jobs and deployments and other stuff come in, and we're gonna talk about them. So indentation, yes, it does matter. Sometimes you might see random errors that Kubernetes might not like if either indentation is not identical or if it's between tabs and spaces. Sometimes it doesn't handle that gracefully depending on encoding. And the one thing I would like to point here is that it is tricky to stick to policy, to stick to being, let me call it a good citizen. So it's easy to misconfigure a YAML to do something bad, like request too many resources or sleep. Sleep is a command that lets me, basically, it's a sleep command. If I run sleep 36,000, this is 3600, my bad. This is in seconds. This is running a command for an hour. So that means my pod will run for an hour, which means those resources I'm requesting are going to be running for an entire hour. So imagine now we're requesting eight of the cluster's most powerful GPUs and I'm idling them for an hour. At that point, you don't have an allocation that says you get X amount of GPU hours. You get to reserve within what is available. At that point, when you're idling GPUs, you're hurting other users. So YAML configuration and not idling resources are sort of a thin line to sort of tread, and where users need to be a little mindful in how they're provisioning resources. And the other things are here, image. So image, this is a Docker image. When I say Ubuntu, what is defining what Ubuntu means in here is that it pulls this term here directly from the Docker Hub registry. So I'll just assume that everybody's familiar with Docker and what Docker is, but Docker Hub is a registry that has a library of images. So when I say Ubuntu, it's pulling the default for Ubuntu from here and assuming I'm pulling latest because each image has tags. So that's what it's attempting. If I mistype and I call it Ubuntu, will that succeed? Depending of if there is a misspelled one on the registry. So this pulls directly from the registry, assuming I don't specify otherwise. So let's go to the Ubuntu one. Let's assume I'm pulling something very specific, like this noble image with this exact tag. If my application calls for a very specific tag, I can just copy and paste this and pull this one instead. Of course, Docker Hub is the default one, but there's no set list. For example, we host our own GitLab. So when we host our own GitLab, part of what's in GitLab is uh, container registries. So you can host your own GitLab images, and that's part of what we're going to do tomorrow. You can host your own GitLab images and use your own built images, either from GitLab or from Docker Hub. Let's say you're a Docker Hub user, you have an account, you sign in, you build a private image. You can also authenticate and pull a private image. So it doesn't have to be a publicly available one, it could be your own private one. And we have documentation, and we'll be more than happy to show you how to authenticate into your registry and pull your own specific image. But now, for the sake of simplicity, I'll show you just pulling this specific one. Limits and requests. So requests are the lower bound and limits are the upper bound. If the disparity between the two is high, that could lead to issues. So always, as a general rule of thumb, always try to match your limits with your requests. And if need be, try to limit your increase in your limits to be just 20%. Because just to explain how the Kubernetes behavior goes, if I set my requests to equal my limits, my CPU requests are mine. They don't get moved around. So I get better quality of service if this number equals this number. That's just how Kubernetes works. But let's say I set my CPU requests or memory. If I set the requests to be a lower number and the limits to be a higher number, and that would schedule on what is available in the lower bound. So let's say I want one, for the sake of simplicity, I want one CPU core as the minimum, 100 as the maximum. One as a minimum, it's very easy to find a node with one CPU core available and start me on it. Then if my application consumes a lot, it is going to be disruptive for others once it starts consuming up to 100. If I set the request as at 2, Kubernetes will tell it don't use beyond 2. But if I set this as at 100, it will disrupt other services. So that's one thing where I need to be mindful and where I get one dedicated core if I set this to 1 and 1. Now you can see here in my example, I'm specifying a different way of saying it. So 1, we agreed that 1 is a CPU core. 100M, you can think of 100M as a tenth of a CPU core. So the same consumption as 10% capacity of a CPU core. And this is 1% capacity. And same thing with memory. MI is just a megabyte. I can say GI and this will turn into gigabyte. This won't succeed because my limit is lower than my request. This will succeed, but it's relatively a high number. So if you don't need 100 gigabytes of memory, you shouldn't be requesting 100 gigabytes of memory because they will be sitting idly. And lastly, command. So for those of you familiar with Docker, this is the same command argument or command for your entry point in Docker. So for this relevant container, it's pulling this image and running this as the command for the entry point. So it's just running shell, and as an argument from the shell, it's running hello from NRP. It's echoing that. So it's printing that, then sleeping for an hour. So I'm going to take this exact same one, but I'm going to name it something specific. This is just a random number. If you're in the MFSADA-temp namespace that we created just to follow along, please make sure to name it something unique. Otherwise, the folks on the meeting know if you have the same pod name, this will collide. And once I take this, like I said, I'm calling it my pod-YAML. I can just, the convention is kube control apply dash F and then my file name, which is I hit tab to autocomplete and it's my pod-YAML. And I try to apply this. You can see pod test dash pod dash mfsada dash 2131 went through. Now, when I say get pod or get pods, same thing. You can see it. First time I ran it, it was in container creating, and now its status is running. It's been running and it's 11 seconds old. Run it now, it's 22 seconds old. Now, if I don't want to create any files, I can just follow this naming convention, convention. So cat is the same command would list the contents that we mentioned, and into a file, end of file. This is just a keyword that ends. I can just basically I can paste my YAML in here instead of creating a file every single time if I'm not comfortable if I'm not comfortable with using Kubernetes with using Jupyter Hub for editing Kubernetes files. And if you're getting admission webhook messages, so admission webhook is a layer of protection. It catches pod definitions or deployment job definitions that shouldn't be submitted for one of reasons. Normally, those commands are verbose. So if you get a command that, for example, I'm just going to copy and paste the command here just to show you. So if you get a command like this one, I'm just going to paste it here. So it denied your request and it's asking you to fill the namespace admin description and publications and whatnot for the namespace you're running in. That means you have to go to the namespaces and fill those in. Now I realize I added some of you to a namespace and I didn't fill out the fields myself, so I'm just going to show you how to fill them out. Just going to click on the namespace. PI, I'm just going to say not applicable. Grant, I'm going to say not applicable. Please make sure the description is descriptive and not generic. So our namespace to run Kubernetes and test NRP is the exact opposite of what a good description would be, but saying Kubernetes, so it's specifying. So Kubernetes, Jupyter Hub, and Python testing environment. Where will testing GPU provisioning, for example, is good. Institution list, it drops down from a very massive list of institutions. If for any reason your institution is not here, please let us know. You cannot submit in the default namespace. So if you're getting error messages that say the default namespace, you need to go back to this command. So one thing to show you here. So if we ran this command earlier, let me. So I set the config here to my namespace that I do have access to. I'm just going to send it here in chat. And this allows me to set the default as my namespace. Now, let's say I didn't specify it. Actually, let me finish here. Sorry, I got distracted. Python Kubernetes not applicable, and I click save. At that point, I can use the namespace and it will go through. Now we go back to this one. Let's say I didn't specify the namespace and I want to apply this. I can still do the k apply dash f and then the test file. Sorry, not k, kube control. I just have it as an alias on my local machine. This is k. This is slightly less time to type in than kube control. And then you can just add dash n like this. Sorry, not file name, dash n namespace. Namespace name actual here. I'm just typing all this whole thing so you don't have to, so you know it's Unauthorized to save, please make sure you're saving it from your local directory. So forward slash in here, when you open this in here, you can save in here. If you could create a new file and type some stuff and file save, you should be able to save in here. Uh, Sorry, Steve, can you send me the namespace name so I can look at it? Oh, so for my namespace, since I'm the namespace admin, it needs the admin role so you can actually modify those fields. So I modified it for the names for the temporary one. So right now, uh, until you get the admin privileges, you can just type in. It should go through now without typing anything else. And I see a question on how do I add Milvus database to my namespace? So this is actually a great question. So let's say I'm a namespace admin. You can see here, I'm just listing my role here. You can see me as admin and you can see your role here. Just for a quick overview, anybody who is a PI or a lab instructor or a postdoc or works at campus IT or is any management on a campus level or at an organizational level, basically anyone who's not a graduate or undergraduate student can be a namespace admin. Now, if you're the first person from your institute, the process to do so, and actually, let me send the link here from, let me send it in chat. So the process to be namespace admin and or user. So the process is here and I sent it. So the first person from your org, assuming that's you, you can ping us and we can make you namespace admin. After your namespace admin, your role will be like, for example, like mine, and you can just add other users in here. So once they log in, you can type in their name, click add them to the namespace, and you'll see a button like this one that says make admin. And at that point, you don't need us. So if you're the first person, that's where it is dependent on us. You ping us, we add you. If someone from your institute already exists, and you can check this from the map, and you can check this also from here. Instead of waiting on us, they can also add you as the namespace admin, and they can promote you to an admin yourself. And at that point, you get more privileges. So some of the privileges you get is you get to edit the fields of your namespace. Another privilege you get is this is my namespace. This is what I clicked on, what I'm editing. The current features, I can't modify it because they're immutable. It's already been created. Of course, if you ping us, we can peek under the hood and actually change them. But let's say you want to use the Milvus feature, you can just scroll down to create subgroup, and you can just create a subgroup completely for that. And if you're not going to be using Git for Kubernetes, you can uncheck this. Let's say you want to access the LLMs and the Milvus. So Milvus is a vector database, which is very good for RAG applications. Actually, there's a small example in the bottom. Actually, let me see. So this is not the okay. This notebook is slightly outdated. Let me check that one. So NRP dash Nautilus. So we do have a Milvus example. Let me see if it's on here. If it's not on here, we'll upload it today. Ah, here it is. So in the notebook, let me send the link. So in the training material, if you scroll down, there are examples of using RAG with Olama and using RAG with Milvus. And of course, this is dependent on using our Milvus. Milvus is just a vector database system. We have a Milvus operator that runs in Kubernetes, which means one Kubernetes native way of hosting Milvus. Of course, you don't have to use that. You can still run Milvus within your container, within your pod. It's just hoping to cut down on the work. And then once you click on this, you can just call it whatever you want, as long as it's lowercase and doesn't have any characters that are not alphanumeric or dashes, and is a little descriptive. So Milva's dash test is a little too generic, but for example, my name or my campus or my lab dash Milvis is perfectly fine. And then once this refreshes, in a minute or two maximum, you can see it shows up here. And it's in yellow to differentiate. And that means it created a database for me called Milvis dash MFSADA dash temp dash Milvis. And you can use it. And now to go back to this one here. So if you don't specify the context, you have to explicitly provide it as a namespace name. So when I try to apply here, you can see it should not go through because there is no namespace called namespace name actual here. But if I go to MFSADA and look what happens here, it says unchanged because it looked at my command as an attempt to change it. Because if I list my pods in my namespace, you can see I already created the pod and it is running. So an attempt to apply the YAML that is calling it the same name, Kubernetes call looks at it as an attempt to change. So let's say I'm just going to show you something. Let's say I changed the image name and I run apply again, configured. You can see here running. So right now it took see what's happening here, took my apply message as an attempt to modify the pod because there is an existing name. And it changed the YAML inside based on my pod. Now, and the pod scenario didn't change much because my pod is already running, but sometimes you might mistakenly change things if you're not careful with naming. There's another command called create. Create is different from apply. It doesn't take create as an attempt to modify. It takes it as an attempt to strictly create. So you can see that one didn't go through. And delete, so kube control get pods. I'm going to show you some of the things you can do. So first thing is logs. So kube control logs and pod name. No need to say pod, just logs, pod name, and then dash n namespace. Or you don't have to say dash n. And the reason here is because I ran my pod, right? My container is running, but if I'm telling it echo and print and do stuff, and where's the logging going? Where when I say echo this string, where is it echoing? Where is it printing? That is in the Kubernetes logs. So the Kubernetes logs are, you can think of them as the output buffer of the pod. So if my Python script that is running in the pod runs print, that print goes to the pod logs. So kube control logs, you can see here, lists what I have put in here. And I'm looking at a different pod. That's why the message is different. Ours is all in here. And then to show you kube control and exec, exec is execute. It runs a command in a pod. So if I run kube control exec and from my pod, I run echo hello. This hello here came out to my terminal because it executed the command and came it out all the way to my terminal. So if I say uptime, or let's say date, it echoed date. If I say date as a command, give me the date. Now, whether or not this will succeed is depending on whether or not the Docker image I ran, which is Ubuntu in our case, has the command date. If I say sleep 10,000, now you see what happened here? My pod is running the command interactively. So as long as it's running sleep, this terminal is running in the foreground. The command is running in the foreground. But if I say sleep 10,000 in the background, then it's running sleep 10,000. Now it's running in the background. Now my pod won't exit in the 1 hour mark. It's going to run longer. And if I want to interact interactively, I can just add the add the parameter dash IT, which is short for interactive, and then I can just run bin bash. Of course, this will succeed when my pod has a bash shell. If it doesn't have a bash shell, this might fail. Then I might have to use bin sh, for example. Now I'm inside my pod. So this is running from the remote source, the remote resource that is on running on NRP. So if I run psaux, I'm listing the commands that are actually running on the actual pod itself. So this is the command it started with, the sleep that is in the file, the first sleep that I interrupted from my exec session. So it's not running in the foreground for me, but it still sends it to the pod. So you can see it running here, and the second sleep command here, and the bash session I opened, and lastly, the processes I listed. And just to answer some questions in the chat, mypod-yaml needs to exist when you're applying it. So this is an arbitrary name that I named the file and I'm in my home directory. Let's say I created a new folder and called it tests and moved the file here. Now when I go to apply it, it's gonna say didn't see it. Then in this case, I need to specify exactly where it is. And now you know how to exec into pods. Now, last thing, delete. You can also kind of expect what the delete command is. Delete, I need to specify pod. Because when I'm execing into something, the only thing I can exec to is pods, so it knows I'm talking about a pod. When I log something, so kube control logs, there's no pods to be listed because I can only log pods. But get and create and delete, I need to specify what I'm talking about. So in my case, I'm deleting a pod. You can see deleted here, and the terminal is still lingering. It still hasn't exited. That means it's still in the process of creating. So that I have to wait on. If there's any sort of technical issue where this never finishes, that's where you ping us and say something doesn't look right. But other than that, just wait on it to terminate the container and exit, and then it finishes. Actually, let me show you another one. Hope I catch it in time. So kube control get pods. You can see it. Okay, we caught it in time. It's still terminating. So I do have to wait on it. After it's done, you can see it exited. So exited with exit code, and I can just get pods, and it's all gone. And I can create another one. And oh, perfect. So what I call the file doesn't matter. So I'm calling the file my pod, but I can call it example one. I can call it sample. I can call it my own private example that no one else should see. I can call it I can call it an Alpine container and run Ubuntu, and it doesn't matter because this is just the name of the file that we're using. And what the pod's name is has nothing to do with the file name, and what the container name has nothing to do with the pod name, and so on. Now this is a pod. Pods on NRP, based on NRP's policy, they run for a few hours. If I remember correctly, for I think 4 hours and or 6 hours, and then they exit. And the reason is because a pod is your first attempt at using NRP. So odds are you might submit pods that you don't need, and you're just submitting an example. If pods were to live indefinitely, that would lead to a pileup of misused resources or underused resources. So if you use a pod, you have to delete it. If you don't delete it, it will get reaped. But the thing about how you use resources is that not all resources you use are interactive or need to be reaped, and that's where jobs come in. So the difference between a job and a pod is that a job, like we said, since pods are the way you run interactive something interactive, a job is something that actually uses a pod. That's what it launches behind the scenes. And it can use multiple pods. And there are concurrency parameters that you can submit a job that runs 10 pods at the same time, and they will run the same workload that you specify in the job. The difference between a job and a pod is that a job is scripted to run A to Z to finish in a complete scripted fashion. No idling, no waiting, no interactivity whatsoever. So batch jobs, just like if you're coming from HPC, they're supposed to be scripted. So the difference in policy between job and pod is that here's my job. The difference here is that I'm running job. I'm gonna go over the other differences as well. But let's say I run sleep, then 1000 here. With the pod, that was fine. With the job, there's a difference in policy. Now this is a job definition that is violating policy. Because by definition, uh, jobs are meant to be interactive. Sorry, jobs are meant to be scripted, non-interactive whatsoever. So if I run sleep, that's not good. If I run Jupyter, let's say I'm running an image that has Jupyter inside it and I launch a Jupyter notebook from my job, that is also against policy. So you can think of it as batch jobs that are scripted to run the workloads and exit should be in jobs. Testing, debugging, connecting to IDEs, running Jupyter, all running a desktop environment, all of those interactive workloads and debugging and writing code workloads, those go into pods, but not jobs. So in a lot of cases, your workflow will be I design and script and test and prototype on pods once it's mature enough to scale up to, let's say, request 20 GPUs, 100 GPUs. That's when I run a job or multiple jobs. So you don't have to, consolidate everything into one job. You can submit multiple jobs. I see a question. Will a job.yaml file be accepted with a sleep command? So will it be accepted? Yes. Will it be caught after? Yes. Because it's not a static policy that is, oh, we catch a sleep command and then it gets admitted at that point. There's multiple very creative ways to run sleep without running sleep. So endless loops, code that automatically burns cycles, uh, that all goes beyond submitting. So it can be submitted, but in retrospect, it gets caught. And that's the thing here. So anything that is an intentional waste of any hardware cycles will be very severely against cluster policies. And the reasoning here is that you'll be wasting resources, especially this is very severe when it comes to GPUs, because any attempt at idling GPUs is basically telling other users you have to stand in a line and in a queue to request those GPUs. So that's why we sort of have to be strict when it comes to policy, when it comes to idling resources, because normally on other platforms you get an allocation. You get this much CPU hours or this much running hours. Here on NRP, you can request a lot. You can scale up very high as long as you're not wasting any resources. So like I said, you can't run Jupyter in a job, and jobs have to be scripted. Now, cool thing about jobs here, you see in specification, here's the template for the job. So the template specifies how the pods inside the job should run. So let me call it sample job and FSADA and just a random number. You don't have to specify. The naming convention is just mine. It doesn't have to have dashes or multiple phrases. It can just be one letter just to show you. In container, I can just call it container. There's also no naming convention. As long as it's alphanumeric with dashes, you should be all set. It runs the echo job and then exit. The echo command and exit. Requests and limits. I'm just going to show you an example of running higher, even though we don't have to. Restart policy, that means if it crashes, does it restart or not? And back off limit is how many pods are allowed to restart in case one doesn't end gracefully or crashes or something happens to it. And you'll see, we're not going to get deep into detail, but there's different parameters for jobs and to customizing how they run. But just to show you, I'm modifying it in the same file. So you can see I'm still uh, submitting from my pod.yaml, but it's not a pod. Oh, sorry, cube control. It's not a pod, it's a job. I'm just misleading with the file name. And now if I run cube control, get jobs, you can see I'm running only one job. Its duration, age, 6 seconds. Completions, it's only running one pod, and the status is running. Now, if I run kube control get pods, you can see I already had those pods already. Those are old pods from before the tutorial, but this is a new one. So you can see the Kubernetes naming convention. It named it behind, so it named it after the job. So it called it A dash and then the random suffix. And then it's in container creating. If I run get pods again, it's in container creating. I can run kube control, describe pod. This will give me a very long description of the pod. So you can see this is the pod name. It's running in my namespace and whole other information. You can see it's scheduled on a node that is actually in Czech Republic and start time and the commands it runs, containers, and controlled by the job. So that's the difference, is that the pod is controlled by the job. You can see here in my description for events, so failed to create was container was oh, okay. Memory limit is too low. Let's try again. So you can see from describe, I can look at events and I can know if something is bad. Now I can try, for example, to delete the pod. And like we said, you have to wait on it to delete gracefully. So let me list the pods here. You can see, oh, here we go. So from listing, you can see as soon as I listed, it listed one with a different suffix and it's container creating. And if I list kube control get pods dash O wide, so this is just the output format is wide, which means add more columns, the wide view. You can see node, it's scheduled at a node at Fullerton here in California. Well, another time, and we can see get pods. We can run kube control, describe, pod. You can see same thing happen. So I know something is bad with my job. I can just run kube control, delete job A, and I can go back here and I can see here's what our issue is. So you can see even live, this wasn't rehearsed. This is an honest mistake. I did misconfigure my YAML. So you can see I set 1M. So that's 1,000th of a CPU core. So that's not a sliver I can actually get. And I set the memory to be 1 MB, which is extremely low. So it crashed. So this was an honest mistake. We can apply again. You can see here it's container creating dash O wide. It's starting at a new node. I can describe the pod itself. And you can see here, no space left on device. We'll check on this is so just to give you another case like this. So you can see here I'm seeing an issue with like this. I don't know what this is. I send the admins take care of it. This here also another unrehearsed issue is an issue with the node. So the actual server we got scheduled on. So let's try our luck again. We delete the pod. You can see it started another one. And you can see here, it started another one. If I kill this one, it won't start another one because the back off limit is 1. Of course, I'm setting this one. So if I set it to 3, I'm allowed 3 more restarts before it decides, oh, this is a bust. It's not going to work. And I can run describe pod and I can run describe job, and both have different outputs. So you can see the describe of the job, it's more descriptive of the job. Its name, who submitted it. So you can see whenever you submit something, or let's say you're an admin, whenever one of your users submits something, it's annotated with who submitted it. So this is my NRP username, basically. You can see created pod here. This is the first one, this is the second one. And now I can run kube control describe pod. And hmm. It's not liking this today, is it? Okay, try this again. And let's see. Oh, my bad. Another issue here is that I'm not specifying units. So CPU, that's fine. The unit is core. So I can say one CPU core, one CPU core. Memory, either GI, just gigabyte or gigabyte, or MI. So this is very different from this. Sorry, this is different from this. I have to specify to reduce issues, and let's try again. Hopefully we won't get the issues this time. And let's see. All right. Now we have luck. You can see we have better, more optimistic messages and events. First one is that it assigned it to a node. The second one is that it's pulling image Ubuntu. So pulling image is the last step before running. So once we get to pulling image, that means all the previous steps have succeeded and it's going to pull the image. It pulled it and then it started the container. Now we're on kube control, get pods. You can see it completed. The reason it completed is because the entire commands it ran are just the entire commands it ran were just, where are we? Where are we? Oh, sorry, my bad. Got lost. Yeah, here we go. So the entire commands it ran were just echo hello from NRP job and then exit 0. And now if we run back again and run it, you can see, sorry, not run it, but get the logs, kube control logs of this. You can see in the logs it added hello. And then lastly, you can just look at the, where were we? Describe pod, started container. The other issue here is that exit 0. So completed because it exited at exit 0. If I say exit 1 is exiting ungrace, like exiting with an error code basically. So if I run kube control, delete job A, and I resubmit a new one. So kube control apply dash F. Then I get pods, container creating. Let's wait on it a little bit. Let's describe pod. Sorry, I'm used to typing K instead of kube control. Describe. Started container. Now, if we look at the pods, you can see status is error. That is, of course, just that is me saying it's an error. So how you exit the pod based, so this is completely scripted. How this runs in your pod is completely up to you, and you can actually script it in your custom code running from your custom Docker image. So it doesn't have to be Ubuntu, it could be something you're running. How your job pod exits is up to you. So if you design the code to indicate an error and exit ungracefully beforehand, you can tell Kubernetes then that this was an error here, and you need to start a new pod to reattempt or show me the errors. Of course, you can see here, so just pulling to our previous example that said completed, In this example, that set error, you can see those pods on here, those exited. I can't no longer exec into them. I can't no longer interact with them, but I can still see them. And the reason here is because in my job, I set a TTL, which is a time to live, seconds after finished. So for 300 seconds, those will be here, and as long as I don't delete the job. And that's for where errors happen. I want to look at the issues. And I'm just gonna pause the recording here or stop the recording.